Welcome to the guided reading and notes for the motion. Today we're going to be focusing on distinguishing between speed, velocity, and acceleration. We'll do that by defining speed and learning how to calculate speed. Remember our essential question for this section. How does an object's speed and acceleration affect its motion? Simply said, speed and acceleration directly affect an object's motion. Now let's think about the equations. A relationship in mathematical sense means an equation between distance, speed, and time. Mixing up distance, speed, and time. A common type of question in physics is, how far did you go if you drive 2 hours at a speed of 100 kilometers per hour? You know how to get speed from the time and distance. How do you get distance from speed and time? The answer is the reason mathematics is the language of physics. A mathematical description of speed in terms of distance and time can easily be arranged while preserving the original connections between the variables. The letter V stands for speed, the letter D stands for distance traveled, and the letter T stands for the time taken. I'm going to highlight that because that seems very important. T stands for time taken, V stands for speed, and D stands for traveled distance. You can now write a mathematically precise definition of speed. This is our equation for speed. Speed is velocity equals distance over time. I like to make an equation to help me rearrange this quickly. Here's my triangle. I always have to put the V here, the T here, and the D here. This will help me rearrange the equation. But I also see the different forms of speed are down here. This gives me the equation if you're looking for something else. If you know distance and time, you take V equals D over time. Remember, the words or letters stand for values that variables have. For example, the letter T will be replaced by the actual time when you plug in the numbers for the letters. You can think of each letter as a box that will eventually hold a number. Maybe you do not know yet what the number will be. Once you get everything rearranged or arranged according to the rules, you can fill the boxes with the numbers that belong in each one. The last box left will be our answer. This will help us. You can think of these as boxes, and we'll have to put our numbers into there. So let's fill out our guided notes. The V stands for speed or velocity. And then you're going to fill out the rest. Here is the words or the last paragraph of our reading. And I want you to fill these out. V, and here's the equation, blank divided by blank. D equals blank times blank. Use your triangle that we've created. Remember, V always goes here, T always goes in this box, and D always goes in this box. So all you have to do is cover up D, and this tells me that V times T. You do the other ones for time and for velocity. So how do we calculate speed? Well, here's a few examples. What is the speed of a cheetah that travels 112 meters in 4 seconds? So I am looking for speed. I am given distance because I know that the meters is a unit for distance. So D equals 112 meters. I'm also given time because I know that seconds is a unit of time. I make my triangle, VTD. I cover up what I'm looking for. So this tells me that V equals D over T. And now I write in my solution. So these are my boxes. So I need to fill in my boxes with actual numbers. D was 112 meters. T was 4 seconds. So this gives me, let me get out my calculator, a speed of 28 meters per second. I'm going to go back and make sure I have everything I need. I have my equation, check. I have my work, check. And I have my units, check. I'm good to go for this equation, or for this problem. Let's do another one together. A bicycle travels 60 kilometers per hour in 3.5 hours. What is the cyclist's average speed? Well, I'm looking for speed. I'm given distance, because I know that kilometers is a unit for distance. And I'm also given time, because I know that hours is a unit for time. So I'll make my triangle. V, T, D. Always fill out that way. I cover up what I'm looking for. So my equation, or my relationship, is D over T. Now I need to fill in my boxes. D equals 60 kilometers. T equals 3.5 hours. I do some number crunching here, and I get about 17 kilometers per hour. Now, go back. Do I have my equation? Yep. Do I have my work? Yep. Do I have my units? Yep. This is a successful problem. On your guided notes, they're going to do the exact same problem, but you're going to be looking for actually the time. All right? So I want you to be able to rearrange the equation to look for time. You can check to see if you correctly solved for time because it's given in this equation right here. That will be your answer. All right, so let's go back. What did we learn today? Well, we defined speed and we calculated speed. This will help us answer our essential question of how does an object's speed and acceleration affect its motion. Thanks.